Welcome to a lesson with Dr. Powell. In this video, we will look at a practice problem that deals with verifying that the MN definition of a limit is satisfied for a particular situation limits statement. Okay, so as with the other ones, the other practice problems, when you're ready, pause the video and try it out on your own, and then keep it going to see the solution. When you mark, get set, pause the video. Okay, now I'm going to go over the solution. Okay, to this, how we can verify this. First of all, what is this statement? So as with the others, we kind of always have like given a y closeness there existed, a y closeness to this, right? A y closeness to, so given a y closeness to this, which is, so, and in particular, let me just make sure I don't have a stray mark here. Okay, so given a y closeness to negative infinity, what's a y closeness to something infinite? That's an m. So we say given m, then what we want to say is we're going to figure out what the x closeness to this should be. An x closeness to something infinite is an n. So let n equals something. Then if, notice that x is getting, we want to be getting things bigger than infinity. So, bigger and bigger as we head toward infinity. So if the x values are bigger than n, so then if x is bigger than n, then we want the y values to be getting close to that guy. So be lower than the m value, right? M is a position, so it's kind of like to represent getting close to negative infinity, which isn't really close, but represent the idea of going without bound down that way. We're going to say that the output of the function is going to be less than m. Okay, so then if x is greater than n, then the output of the function, I'll just call this the function right here, f of x, then f of x will be less than m. And we got to figure out what this n is going to be equal to right here. That's the question. Okay, so let's take a look at a picture. This is a downward parabola, right? We're just trying to practicing verifying the statement. In particular, finding the relation between the n and the m. So given an m, what can n be that would satisfy this for this particular m situation? Well, okay, so given a position m, that's like value y equals m, right? Okay, so the idea is, what does n have to be so to guarantee it that if x is on this side of it over here, that we're going to be lower than y equals m. Again, point of exit entry is perfect for that. This position right here, so this position right here, x would be a good candidate for n, because if x is bigger over here, then the values of the function are going to be less than m right here, going downward. So what do we have? All right, so we got to basically figure out what this n value is in terms of m in the situation. Well, we know what this is, what the y value at this point is, knowing what the function is. The function is negative x squared. So at this point, you can think the y value is, you just plug in the x value to give you negative n squared. But I also know it's equal to m. So I know that m and negative n squared are equal to each other. So this tells me in particular that, so I can go negative m, and then I can take then n squared is going to be equal to that. I want n particular to be positive as I head off to infinity, so I'm going to take a positive square root of that. Now notice this is good because m is actually going to be very negative as it goes down, So a negative number is going to be positive. So I really am taking a square root of a positive number here. So I'm going to be taking the positive square root because I want n in particular to be positive as I'm heading toward infinity. So here's the relationship between n and m. All right, so this is what n should be equal to. N will be equal to the negative square root of m. Then if x is greater than n, then we know that this is, and we can see that by the picture, it basically is the picture. I just verified in the picture the relationship between n and m computationally right here. And that would be it for that practice problem. Thanks for watching.